Welcome, my name is Dr. DrWedding, and this is DrWedding DC27. Maximum Power Transfer. In this video, you will learn what maximum power transfer is and how to pick the correct load resistor to achieve it. The video will also go over different ways your instructor may ask the same question. Your first question is probably, what is maximum power transfer? Maximum power transfer is when you deliver the most power to the load as possible. This is very important in electrical engineering. You want the maximum battery power delivered to your electric car. You want the maximum power delivered to your stereo speakers. And you want the maximum power delivered to the burner on your stove. The second question you are probably asking is, how do I get maximum power transfer? Maximum power transfer happens when the load resistor is equal to the Thevenin or Norton resistance. It does not matter if you are working with a Thevenin circuit or a Norton circuit. When the load matches the Thevenin or Norton resistance, the load will receive the maximum power possible. If you do not know what a Thevenin or Norton circuit is, you need to go back and watch DrWedding DC24 and DrWedding DC25. To truly understand maximum power transfer, you should see a graph of the power versus the load. Assume you have this Thevenin circuit. Next, plug in a resistor value for the load and calculate the power dissipated by the load resistor. Change the resistance and repeat the process multiple times. Then plot the resistor value and the power dissipated by the load. The previous circuit was used to generate this table. The first two columns are the Thevenin values, and they are fixed. The third column is the load resistor, and in this example, its value starts at 610 ohms and will be increased until it reaches 970 ohms. Using the total voltage and the total resistance, the total current can be calculated. The voltage across the load can be calculated using the voltage divider rule. And the power delivered to the load is the total current times the load voltage. This is a lot of information, but we only care about how the load resistance will change the power through the load. So we are going to plot these two columns. This graph will plot how much power is delivered to the load resistor over a wide range of resistances. The load resistance is on the x-axis, and the power dissipated by the load resistor is on the y-axis. Now, it is easy to see that when the load resistor is 750 ohms, which is the value of the Thevenin resistance in this circuit, the power delivered to the load is at a maximum. If you already know more about maximum power transfer than you did 3 minutes ago, please hit the like button and leave me a comment. This will help introduce these videos to other students who might be struggling. So, for maximum power transfer, you will set the load resistance equal to the Thevenin resistance, or you will set the load resistance equal to the Norton resistance. You may be wondering, is that all I need to know? The answer is yes and no. The answer is yes, if all you need is the resistance for maximum power transfer. The answer is no, if your instructor asks more questions about the circuit, or if the instructor indirectly uses the load value to ask a different question. I am going to solve some questions that your instructor may give you when covering maximum power transfer. Question 1 is the easiest question your instructor can ask. What load resistor value do you need for maximum power transfer? The answer is the same value as the Thevenin resistance, so the load needs to be 800 ohms. Question 2 is equally easy. What load resistor value do you need for maximum power transfer? The load value would be the same as the Norton resistance, so the load needs to be 400 ohms. Question 3 is a little harder. When the Norton circuit is delivering the maximum power to the load, what is the current through the load? Maximum power transfer happens when the load resistor is equal to the Norton resistance. Because the resistors in parallel are both 800 ohms, they equally share the Norton current. Both resistors get half of the Norton current. So the load resistor will have 5 milliamps flowing through it, and the Norton resistance will also have 5 milliamps flowing through it. Question 4 is the same as question 3, this time with a Thevenin circuit. When the Thevenin circuit is delivering the maximum power to the load, what is the voltage across the load? Maximum power transfer happens when the load resistance is equal to the Thevenin resistance. So, the resistors will equally share the Thevenin voltage. So the Thevenin resistance will have a 3-volt drop across it, and the load resistor will also have a 3-volt drop across it. Question 5 is similar to question 3 and question 4, but it is asking for a voltage in a Norton circuit. When the circuit is delivering the maximum power to the load, what is the voltage across the load? Maximum power transfer happens when load resistance is equal to the Norton resistance. So, the resistors will equally share the Norton current. Once you know the current in the load is 5 milliamps and the load resistance is 800 ohms, then Ohm's law can be used to find the load voltage is 4 volts. Keep in mind, there are a lot of other ways to get this answer. You could have calculated the total resistance of the two 800 ohm resistors in parallel and got 400 ohms. And 400 ohms times 10 milliamps is also 4 volts. Question 6 is a little harder. What is the maximum power that the load resistor can dissipate? The maximum load power happens when the load is equal to our Thevenin, so the load resistance is set to 750 ohms. You know that when there is maximum power transfer, half the voltage is across the Thevenin resistance, and half the voltage is across the load. This was demonstrated in question 4. If you forgot that fact, you can use the voltage divider rule. Either way, the load voltage is 7.5 volts. The current through the load can easily be found using Ohm's law. And once you know the voltage across the load and the current through the load, you can find the power dissipated by the load is 75 milliwatts. In this question, the instructor did not directly ask for the resistance, but you needed to know what it was in order to get the voltage, current, and the power. Question 7 is a trick question that your instructor may give you. What is the load resistance if the load current is 15 milliamps? Don't assume it is a maximum power transfer question unless you actually see the words maximum power transfer or some similar wording. This is not a maximum power transfer question, and the answer is not 750 ohms. The question told you that the total current is 15 milliamps. And when you look at the circuit, you can see the total voltage is 15 volts. Using Ohm's law, you can find the total resistance of the series circuit is 1000 ohms. But be careful, this problem used the total voltage and the total current. So this is the total resistance. This is not the load resistance that the question asked for. The total resistance is the sum of both resistors. So the total resistance minus the Thevenin resistance is the load resistance. Therefore, the load resistance is 250 ohms. If your instructor is feeling extra tricky, you might get a follow-on to question 7 such as, how much more resistance would you need to add to the load in order to get maximum power transfer? Now this problem has turned into a maximum power transfer problem. But just like before, the answer is not 750 ohms. For maximum power transfer, you need a total load resistance of 750 ohms, but you already have a 250 ohm load resistance. So the answer is the difference between 750 ohms and 250 ohms. Therefore, you need an extra 500 ohms added to the load. I hope this video has helped you understand what maximum power transfer is and how to balance the load resistor to the Thevenin or Norton resistance to get it. I also hope seeing a variety of different question types will help you on your homework and tests. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.